All right, we are going to work on 2.3, composing functions, composition of functions. Right now we're working on inverse functions. We may actually get to some other just general composition, but I want to make certain that we understand whether or not we have an inverse or not. Here I'm actually going to write this in two different ways. One is we're going to start with the f of x, and then we're going to input the g of x. All right, so I'm going to have my 2. All right, my 2, and I'm going to leave a big old space for my replacement x. This is going to be where I'm going to put my new x plus, plus 6 and then I'm going to go ahead and put in this 1/2 x, 1/2 x minus 3 in order to, this is my input now. I could also have gone the other direction. I could have said, okay, I'm going to put my input, right? I'm going to put my input of 1/2 x minus 3, and then I'm going to put this in, so this is my new x, this becomes my 2 plus 6, right? So you will get to the same way of writing it, whichever way you decide to go, whichever way makes more sense to you, do that. All right, so here we'll go ahead, I'm going to multiply through by 2, so I'm going to have a 2 over 2x. 2 over 2x. Here I'm going to have a negative 6 and a positive 6. So this is going to go to 0. This becomes a 1. So this looks like my x is what I get back out of it. So if that's true, I can go ahead and rewrite this the other way around and should get an x back out of that as well. Remember, inverses are the only time that composition of functions are or is commutative. Otherwise, it is not commutative, and we'll get into some of that with some of the other work here. So in this case, I'm going to go ahead and I want to, instead of it being the 2x, instead of it being the f that's on the outside, we're going to have it be on the inside. So I'm going to have a 2x plus 6, and then I'm going to have my 1/2, right? So here's my 1/2. This is my new x, right? This is the new input, and then my minus 3. I am going to go ahead and distribute through that, so that I'm going to get a 2 over 2x. 1/2 of 6 is going to be a 3, and here I have a minus 3. So again, this goes to 0. This is a 1x. There we go. So these are inverse, right? These are inverse functions to one another. All right. Let's take a look here. What else I have going on? All right, so I'm going to start looking at just straight up compositions. All right, I'm not going to be looking now for whether it's an inverse or not. I'm just going to do the composition. So in this case, we're told f of x is 3x minus 4. My g of x is 2x plus x, and my f of g of x is what I'm looking for. And my x is going to be a 4. I'm told that x is 4. So the very first thing I'm going to do, I'm going to do this first as a chain method, right? So I'm going to have my g of x. So this is the innermost link, right? I need to do this. So I'm going to take my 2x plus x, and then I'm going to go ahead and put in my 4. So this is going to become the g of 4 equals 2 times 4 plus 4. So my g of 4 winds up being a 12. So now my f of 12, maybe I'll just go like this. So my f of 12, right, this becomes my new input. My f of 12 is going to be 3 times 12 minus 4. All right, so 3 times 12 is going to get me a 36, minus 4 is going to get me 32. All right, so this is where you're plugging it in. Here's my first chain, first link, right, in the chain. Here's my second link. And we have put in value in place of the variable. All right, so this is one way to approach this. I'm going to show you another way to approach it. And as I say, most people tend to go one of two extremes. Either they need it to be very concrete, in which case they're putting in an actual number, or you're going to have a very abstract. So you'd wind up with your composition, right? You're going to have this. You're going to have your g. That's going to be a 2x plus x. You're going to put that inside there. And then you're going to have 3. Remember, this is our new x minus 4. And when I go ahead and distribute through, I'm going to wind up with a 6x. Actually, that's, yeah, 6x plus a 3x. So that's going to give me a 9x there. And then I'm going to bring my negative 4 down, negative 4 down. All right. So now I've got this completely summarized. I could have also said, 3x right here. Either way. So at this point, I can say, all right, I'm going to plug in my value now, right? So at this point, I'm going to plug in my, where am I here? There we go. I'm going to plug in the 4. So 9 times 4 minus 4, right? This whole thing. So I'm going to have a 36 minus 4 is going to give me 32. So again, if you want this is the abstract right here. So let's see here. So this is our abstract. And this is our concrete. Okay, this is where you actually are plugging it in. And then you have your actual numbers involved. Here we're starting, we go all the way through, and at the very end we put our number in. So either way, whichever way makes more sense to you, I'm just trying to provide you with more tools in the toolbox. Alright, so this one, this is kind of fun. Here I'm going to have my f of x is going to take the square root of x minus 16. Well, if my x is 20, right, I'm going to have the square root of 20 minus 16. That's going to give me the square root of 4, which is 2, right, plus and minus 2. Here, I'm going to do a little bit differently. I'm going to, sorry about that, I am going to put my 20 plus 16. All right, this is a new problem, very similar to this one, but this one is going to be we're going to add them together. So I'm going to have my g of 20 equals the square root of 20 plus 16. That's going to give me my square root of 36, which is straight up 6, right? So I'm going to have my plus and minus 6 here. Now, this next one, I'm going to put in a 24. All right. So this is the same formula, only this time I'm saying put in a 24 instead of a 20. So in this case, I'm going to wind up with the square root of 24 plus 16. That's going to give me my square root of 40. Now, 40 is not a perfect square, but we probably have a perfect square hiding in there. So let's break it all the way down and see if we can find the things that might cancel out. You know, so if you have a square and a square root, they cancel each other out. So let's go ahead and do that. I'm going to say I have a 2, square root of 2, and a square root of 2. There's my 4, right? And then I'm going to have a square root of 2 and a square root of 5 for my 10. So there's 4 times 10. And if you take a look, this is the same as saying the square root of 2 quantity squared, and then I have this square root of 2 square root of 5, right? And it doesn't matter. I could have picked these two, you know, these two 2's, doesn't matter. Ultimately, what's going to happen here is this square root of 2 and the square of this is going to cancel each other out. So I'm going to be left with a 2 and then the square root of 10. All right? So be aware that even if you don't have a perfect square, you may be able to factor some stuff out so that you have not just some really large square root. You just wind up with some number and then some other smaller square root that would make it less challenging to deal with. All right, I'm going to call this good.